Hi math students! Today's lesson is reviewing laws of exponents and how to simplify expressions that have exponents in them. So we're going to start off with a warm-up, and yes, there are exponents in this warm-up, and it's just to see how much you remember about exponents. So what I want you to do is pause the video and circle all of the expressions below that are equal to 8. Alright, so I'm just going to expose the answers to you right now, but I'm not going to explain them till a little later. So the expressions that are equal to 8 are this one, this one, this one, this one, and this one. They all are equal to 8. Okay. So if you didn't get all of them, or if you're not sure how these work out, let's look at some notes real quick, and then we'll come back to the warm-up. So here are all of your properties of exponents. Some of these might be a little new to you, especially the fraction exponents rule at the bottom. So what I want you to do, this is a lot of notes, so I want you to just write out the table, and then once you are done copying out the table, come back to the video and we'll go through some of the examples together to make sure you understand what's happening here. Okay, so I think that you've probably heard of these properties before, but it's always easy to forget. So the product rule, remember that the word product means multiplication. Multiplication. Product means multiplication. So whenever you're multiplying two bases, two things that have the same base, so two terms that have the same base, you can see all of these have a base of a. Then you can add the exponents. So, in our example, the example has two terms. They're multiplying together. They both have a base of x, which means we're able to add the exponents. 5 plus 3, which is x to the 8th power. Quotient rule. Quotient, remember, means division. Again, you need to be dividing numbers that have the same base. So when you divide numbers that have the same base, then you subtract the exponents. So that will look like this. They both have a base of x, so I can subtract 9 minus 5. This is x to the 4th power. Power rule is referring when you are raising something with an exponent to another exponent. So you're raising a power to a power. So you have two powers that are being raised. What happens there is that you will multiply the powers together. Okay? So here we would multiply 3 times 4, which is x to the 12th power. Negative exponents. So if you're not familiar with negative exponents, the way that the trick with negative exponents is you can turn the exponents positive by moving them from the numerator to the denominator or the denominator to the numerator. So you can see in this case we made it positive. We made the exponent positive by moving the whole term from the numerator to the denominator. And then in the bottom case, we made the exponent positive by moving the term from the denominator to the numerator. So this kind of helps if you just want to have all positive exponents. So in the examples, I see that I have negative exponents. If I wanted to make them positive, in the top one, I would move the term down and make it positive. And then in the bottom case, I would move it up and make the exponent positive. Zero exponents, anything raised to an exponent of 0 is just 1. So in the example over here, everything in the parentheses is being raised to the 0 exponent, so that goes to 1. So this whole term is just equal to 3. And then the final new thing are fractional exponents. So neither of these are really better than the other. It kind of just depends on what you're doing. So both of these ways of writing exponents are good. But basically, this is showing you that if you have an nth root or some sort of root, it's like having a power that's a fraction. So the power stays the power, and the root becomes what you're dividing by as a power. Okay? So if I wanted to rewrite 81 to the 3/4, this would be the fourth root of 81 to the third power. So the fourth root of 81 to the third power. And I could actually raise 81 to the third power first and then take the fourth root, but I have no clue what 81 to the third power is. That's too big of a number. So I always recommend taking the root first to make it smaller. So the fourth root of 81 is 3. And then you can raise it to the power to make it big again. So I recommend taking the roots first to make it smaller and then raising to the power. Let's look back at the warm-up to understand how all of these are equal to 8. So this negative power, I could rewrite this as a positive power by moving it to the numerator. So that's 2 cubed, and 2 cubed is 8. Now I know that when I have a power that's division, that is actually a root. So this is the square root of 64, and the square root of 64 is 8. The 0 power, anything raised to the 0 power is 1. So 8 times 1 is 8. Here we have a quotient rule. So this is I would subtract 4 minus 1. 4 minus 1 is 3, so that's 2 to the third power, which is 8. And then here we have roots again. This isn't I can't apply the power rule here, or the product rule, because even though there's multiplication, they don't have the same base, so I can't combine them together. I can't add the exponents because they don't have the same base. But I can rewrite these as the cubed root of 8 times the cubed root of 64. And you should start memorizing what these roots are. The cubed root of 8 is 2. The cubed root of 64 is 4. Those are ones that you should just know. So 2 times 4 is 8. There you go. That was kind of a tricky warm-up because they were all equal to 8. Alright, we're going to do 2 more examples. This example 1 is focusing on fractional exponents. So we're going to rewrite the following with fractions. So this is just asking, it's not asking me to simplify, it's just saying rewrite it with a fractional exponent. So this is just making sure we know how to rewrite things. So I take my number 27, still being raised to the second power, but because I have this root, the second power is being divided by 3. So rewritten with a fractional exponent, it's 27 to the 2/3 power. Power is 2/3. Okay. Now in part B, it does want us to actually simplify. So we want to make these a more simple number. So I'm going to rewrite these to be 64. The root is 3, since that's the denominator, it becomes the root, and then the power is squared. Again, I don't want to square 64 because that's just going to turn into a giant number, and I want to be able to do this in my head. It's good practice to know these, to have these memorized. So I'm going to take the cube root of 64. Do you remember what that is from the previous page? Cube root of 64? It's a 4, and then 4 squared is 16. Um, Go ahead and rewrite this one first. What'd you get? Okay, so this is 81. The root is 4 and the power is 3. Fourth root of 81. I think we already did this problem. Fourth root of 81 is 3, and then the power of 3 is still there. 3 cubed is 27. This is like a really popular problem on the SBAC. If any of you are 11th graders, and if you take the SBAC, this is a popular question. They want you to rewrite in this form. So this is the form that we want to rewrite these all in. So essentially this is saying we don't want roots, so we only want exponents, and we don't want fractions. So the fractions have to be eliminated and the roots have to be eliminated. So I want to get rid of these roots and I need to get rid of these fractions. See? So we're going to be rewriting. So let's start by rewriting in part A with fractional exponents. I'm going to rewrite with fraction exponents. So the root here, if it doesn't say a root, then it is the square root. So if it doesn't give you a specific number, it's the square root. So the fraction exponent will be 5 halves. And then over here, the fraction exponent is 2 thirds. Because I have the third right there. And now since they are the same base, I can apply the product rule by adding the exponents. I'm adding the exponents. Oh, do you remember how to add a fraction together? You have to get a common denominator. So in this case, the common denominator is going to be 6. So I have to multiply the top and bottom by 3 right there, and the top and bottom by 2. So just a reminder, when you add fractions, you need a common denominator. So I've got to do a little extra work. So this first fraction becomes 15 over 6, and the second one becomes 4 over 6. And now I can add those fractions together. When you add fractions, you only add the numerators, and the common denominator stays the same. So we did a lot of work to make the denominators 6. We're going to keep it that way. So that is b to the 19th over 6. Alright, so there's a lot going on here. I'm going to start by rewriting this without the fraction exponent. So that's the only thing I'm going to change right now. That will be b to the 1/2, since this is a square root. And there was a power of 1. So the fraction is 1/2. Okay, so there are a couple things I can simplify. 12 divided by 3 is just 4. So you just treat the numbers like normal numbers. And then I need to make sure it's in this form. So I need to move everything from the denominator up to the numerator. Okay? So that means I need to move that a up. So I have 4, b to the -1. When I move a up, it becomes a to the +3. And then when I move b up, it becomes b to the -1/2. So my last step is to combine these like terms. So since they have the same base of b, I can combine them together using the product rule. So the product rule says I will add the exponents. So that's -1 plus a -1/2. So that's -1 minus 1/2. And then a to the 3. -1 minus 1/2 is -3/2. So here is the final answer. I want you to take a look at this and figure out which of our rules of exponents are we going to use to solve this. Which rules of exponents do I need to solve this? There's a lot of them. Okay. So the first exponent I see I need to use is the power rule. I see I have like parentheses raised to a power, and so I'm going to just apply that first. I'm going to raise everything in the parentheses to the second power. So negative 3 squared, negative 3 is being squared. I'm just going to write it like that so I don't make any mistakes, especially since it is a negative 3. And then a squared squared, I multiply the powers, and that becomes a to the fourth power. And then this is b to the first power, so b to the first power squared would be 1 times 2, which is 2. So there is my power rule. I'm going to rewrite negative 3 squared is 9. And then I see that I can simplify that. So I know that 9 divided by 6 is 3 halves. I'm going to write it a little different though. I'll just write it like that, 3 halves. Cool. And then I can just use the quotient rule here. So I can use a quotient rule there and there. So the quotient rule says that if I'm dividing by, terms that have the same base, I can subtract the exponents. So here, you subtract the numerator exponent minus the denominator exponent. And then with b, we subtract the numerator exponent minus the denominator exponent, being really careful about those negative signs. So this becomes a to the negative 1. This is 2 plus 3 halves. I can write this as 4 over 2 plus 3 halves. So I'm rewriting 2 as a fraction with a denominator of 2 to make it easier for me to add the fractions together. So this becomes 3 halves, a to the negative 1, and then 4 halves plus 3 halves is 7 halves. And that is the final answer. You could have done this problem a little bit differently than me. There are always multiple ways to do these problems. You should get to the same final answer though. So hopefully you are reminded of all your properties of exponents and how to use them to simplify and manipulate expressions.